That again. Okay, so today we'll be looking at two things. The first is how to write rholang contracts. We're not going too deep or too advanced. We're just looking at the basic things: how to print a screen, how to send processes, how to receive names, and perform concurrent operations with the part. I know we've heard a lot that rholang has the concurrency feature, so we're going to be seeing that. Then also we're going to be looking at how to spin up a node, whether a standalone node or a bootstrap node, which is a node connected to the network, and also how to deploy our contracts on the network and propose blocks. So now from this introduction, we can see that the very basic thing we need to know while writing a rholang contract, or while even practicing rholang contract, is that you need to have a node running or a node repair. Now there is one we're currently working on Discord in the Colab server, although there's some issues with it, but it's okay. We're able to, I think Jim was able to propose and create a block, so that's good news. Okay, so you need at least a node repair or a running node if you want to write rholang contract. And now rholang, it's much like a functional programming language. There are different kinds of programming languages for those of us that are still fresh in programming. There are different kinds of programming paradigms. Rather, you have the object-oriented paradigm, you have the functional paradigm. Now, this paradigm have their different behaviors. Now, the basic difference between the functional programming paradigm, object-oriented allows for sites to making changes to states and variables. We don't, if you're not so much interested in programming, maybe you don't really need this so much technical details for. But for those of us who are quite interested, these details might be interesting for us. Whereas the functional programming, such as Haskell or Camel, it does not allow for change of states. And that's why they are referred to as declarative programming languages. Because once you've declared a line of code, it stands. You don't make changes to the state or the variables in the code. So now the basic thing we need to know about rholang is that rholang it's mostly about sending processes and receiving names. Now I'm just going to keep talking, assuming that we all understand. Maybe from time to time I might take breaks to get questions. If there's anything that you missed or anything that you don't understand, that's okay. Okay, so yep, I'll go on. Yeah. Okay, so the very first thing we're gonna do now is to spin up a node. Okay, I'm gonna kill this node I have running here now. Let me see what process it's running on. Oh, it seems the node is already stopped.
I think there's some lag here.
Yeah, you said?
I think we're having some lag here. We're not seeing your screen change at all.
Can you? Is it better now?
Yeah, we're just seeing the same screen.
Yeah. Okay. What can you see on the screen?
You're in Ripple.
Okay, that's very different from what.
Okay, you probably shared the one window rather than the whole screen.
Oh, okay, okay. Let me get to stop my share then and
Although
share it again.
maybe you should have explained that program that you ran. But you're going to do that later, right?
You said?
Perhaps you should have explained that the program that you ran in REPL, but I guess maybe you'll do that later.
Okay. Yeah. I was thinking I was sharing the whole screen. It's. What can you see on the screen now?
It's coming. Hopefully, it says it's coming. Yep. Now we see very tiny letters in a bash window.
So how is the font now?
It didn't get bigger yet. There we go. That's better.
Better now.
Yeah.
Okay, so you can see, what can you see on the screen now?
You're at a prompt. You got an error on the show blocks command.
Okay, it's not an error. I was just trying to confirm if I have Node running.
Yeah, you don't have
I
it
think
running.
I have.
It's not running. Connect to it. So
Okay, so yeah, so yes, so the first thing we have to do is spin up a node. Now I'm gonna spin up a standalone node. Standalone node is, you could use the -s or the longer flag, which is -- standalone, to start a standalone node. I think much of the instructions are found here. I'm going to paste that in the chat. Yes. Okay, is there anyone following me in what I'm doing? I think it's going to be helpful if there's one person following instead of me just talking. So is anyone trying to set up Node or something?
David, I'm following on what you're saying.
No, what I actually mean is, are you actually running a node or attempting to run a node?
Okay, I'm running one. So I'm looking up at it.
Yeah, I'm running a node.
Okay, what version of node are you running, or what is it a standalone node?
So I thought I ran it in standalone, but this morning I was on node test, so I'm running 0.6.4, and I may be connecting. This is an issue because I didn't clear out my data cache.
Okay.
So like already I'm
so,
connected.
But is the node still running? Is the node still running?
Yeah, it is. Yeah. I think I need to.
Okay.
Yeah, disconnect this. Okay, let me.
You probably want to restart it with a clear .rnode directory.
Yeah. Very importantly, it's important to know that at this point, if you want to run rnode, it's best to use a Linux environment. It's not yet stable on Windows, or Mac. So it's best to use, or most preferable to use, a Linux environment.
Yeah, no, that's a good point. I'm
Okay.
running actually on AWS Linux.
Okay, okay, that's cool.
But
Okay, so let me go back to my terminal here. Yeah, so standalone, then I'm gonna add the no UPnP flag since I'm not using UPnP.
right, that's what I need.
Or first, let me clear out my data directory. So
That's your .rnode directory?
yes, I just cleared out my rnode directory up here. Where is it again? Yes, here. So rm-rf.rnode.
In order
So
to
rnode.
in order to generate blocks, you have to have a validator key, right? A validator private key specified. Otherwise, you can't propose.
In order to, yes, it's to tell you, it's usually says I think weight of 0 or something on slashable block, right? Have a standalone node running. I think on my local machine, I still have a previous version. That is Notebook. I updated it today during the node testing session to 6.4, but this should work since there was no update between 6.3 and 6.4. Then, so now that we have a node running, the next thing is to go to our test editor. Now in the document, you see a comment I included here. Now it's for just additional styling, you could get an extension for rholang file. So I think this is the official support. I already installed that on, this is Visual Studio. So whatever text editor you're using, you just check out the extensions, and if it has or supports those rho extensions, because it makes it, it helps in the syntax highlighting. So the very first thing, like I said, we're going to look at is how to send a process. Remember I said rholang is about sending processes and receiving names. Now, what it means is that it's about someone sending, we could call it like, another word for it is like saying someone sending out an instruction and someone else receiving the instruction or taking the instruction. So let's say I say David, who likes football?
Soccer or football?
Okay, with two of them are the same to me. Which is soccer for you?
Soccer.
I know that America has their own football, so okay.
I like football.
You said?
Yeah, both.
Go on.
Both.
I like football.
Okay, so it means we're going to be using a lot of football examples then. So let's say David pass the ball. So, okay, can you guys see the screen clearly?
Yeah, now you're using what, VI?
VS Studio. VS Code rather, Visual Studio Code.
Oh, okay.
Yeah, so this is the basic syntax for a send operation. So this is the name, that is David, and this is the process that is being sent. So here we're saying David passed the ball. So name and process. So then if we save this file, then we'll go back to we open a new terminal. Okay, so in this terminal, so I think I have the files here, cd. Then if I do an ls, I would see the file that I created on my text editor, which is this file. So to deploy this file, I simply say rnode deploy first.row. Okay, so we're getting a success message, which means it's been successfully deployed. And we can see the deploy here, receive deploy, David passed the ball. So at this point, does anyone have any question or something to ask or comment? Yeah, Priska, are you saying something?
No, Dave, no, I'm not.
Okay. Okay, so there's also another way to evaluate this. Remember I said something earlier that for you to run or for you to evaluate your rholang contract or to run your rholang contract, you either need to have a running node or a REPL. So we could still use our REPL to evaluate the code, rholang code. So we simply say rholang REPL, and then the same thing that we said in our file. Pass the ball. Okay, so now we can see here it's been evaluated here. Now, I don't know if someone can observe something, the difference between the deploy command, that's writing in a file and deploying and using the REPL. Can anyone observe the difference between the two of them? That's between this and this. Who can help us with the difference between these two? Okay, now the basic difference here is that if you're deploying, your gRPC is involved and char is involved, whereas if you're using the REPL, it is only evaluated. What this means is that with deploy, you could make this contract to have a client-side interface, whereas with this is only to evaluate the code that was written. So meaning if I were to build a deploy rather than using REPL. So that's the basic difference between using deploy and evaluating with REPL. So let's move forward to receiving a process. We've sent, receiving the name rather, now we've sent a process. So now we said David passed the ball. So let's try to receive the ball. So the basic syntax for this is, let's say I'm passing the ball to Ned. So so here we can see now what we've done is the first thing we did was we sent the ball from David. That is, David passed the ball, and now Ned receives the ball. And remember, there's something that I know it's quite confusing, especially if it's your first time. Remember we said processes are sent, right? And names are received. Remember, for the first one, the ball was passed as a process, whereas in this case, the ball is received as a name. So to pass this ball back again to someone else, you need a new operator. So if I should say, let's say Victor now. Okay, so now we've passed the ball to Victor. So the reason why we're adding, if you should write ball in this manner, it's going to throw an error. That's the top free variable error. So you need to convert this name ball into a process using the asterisk operator. So if we run this now, okay, so okay, we're getting an error. Okay, we missed something. Yeah. So. Okay. Ooh, that was successful. Yeah, we could see the receive deploy here. So does anyone have any question or comments at this point?
Yeah, could you just dissect that? So at the line 1, at Ned is a process or a name?
You mean this?
Right. So how do you define at quote Ned quote? That's being
At
sent.
Ned is
Looks like we're losing David.
Yeah.
So Net,
yeah.
we can hear you now. I guess we can't hear you now.
Okay, Jim, are you talking?
It was we were getting silence from you, so I just said we weren't hearing you. We hear you now.
Okay, is it better now? Can you hear me now?
I think I can, David. Yeah, David's a little better now.
Okay, yeah. So, like I said, does anyone have any comments? Ned, you were saying something.
I thought it might be helpful for those who are new that we just review like @ned is a what, and that's being sent to ball. Ball is a channel. And then for is not a for loop for those who may be used to an imperative language. For is not an iterator. It's kind of, I don't know what we call it in rholang, but it's more of an imperative, like for this, right?
Okay. Okay. It's an operator for sending names. Or is the operator for sending names rather? Yeah, you guys can still hear me, right?
Not
Sure.
really. You cut out for a while, but now you're back.
David, I have a quick questions. This actually, Ned was making
Okay,
the
so
point. I didn't really get that. The quote at Ned.
okay.
What does it stand for?
So now, okay. Okay. It's a name or a channel. Okay, let me start from the let me go over it again. Now remember we said we send that, right?
Yeah.
Like I said, we send processes and we receive names. Okay, so the very first thing we did was this was the very first thing we did, was sent a process past the ball. Now we're trying to receive that same ball, and in this case, the ball becomes a name. So for which is the receive operator, as a channel net. And I said something that to pass this same name, we have to convert this name into a process using the asterisk operator. So this becomes this. So Victor, is it clear now?
I barely can hear you. It's kind of skipping. Does anyone have the same problem with me? But hello, can you hear me? It's like David is having a connection problem. Hello? Hello, can anyone hear me?
I can. I think we lost David.
It was clear. I got my. Yeah, I was not
I really think what he was trying to say is that you quote a name, and the quote is meant to like kind of change the name into a process. I think I got that to some extent.
Hello,
Hello,
David. David is back.
Can you hear me?
Yeah. Victor, can you repeat what you just said now? I think I
Hello,
got
David.
parts. Yeah.
Yes.
David, I'm very sorry. I came in a little bit late. I'm trying to get what we're trying to do here.
Okay, we're just like
Okay, do you mind?
we're just going through the basics of writing rholang contracts.
Okay. Okay.
So you said that the art quote there is meant to send the name that is Ned to change it into a process that will be executed, kind of like the reason why it's being quoted at is to send it as a process. I think that's where you stopped, and I would like to really know what's the process, what kind of process is it being sent?
Now, what I said was this is the basic syntax for receiving a name. Remember, we receive names, so which means that even if this were to be a process from our previous code, let's say, for example, we have a concurrent instruction where let's say we have David ball. Here, ball is a process, but in this case, ball becomes a name. Why? Because we receive names and send processes. So I was saying that to convert this ball back to a process, I was saying to convert this ball back to a process, we use the asterisk operator. So that's, I think that was where I stopped. So is this clear? The difference between a send and a receive?
Yeah.
I guess where we were.
Yes, if I can.
It's partially clear.
Okay.
Jim, were you saying something?
Jim, you want to?
I was just, I'm still pretty green with this, so I was just trying to address the what Victor was saying about if we have the ball, which is a name, and we quote it to make it a process. And
no, you don't. Okay. You use asterisk to make a process, not quote. You use asterisk to make a name a process.
Make a name.
Okay. You use asterisk to make a name a process.
Yes, to convert a name to a process.
Right. Okay. Yeah, I'm confused. Yeah. So, but I have to go back to the tutorial.
Yeah. So when we have
it's pretty.
Go ahead, Ned.
The name. Okay, Ned.
So I thought we would. So if we look at line 1, we're taking ball, which is a quoted string.
Yes.
Right, and we're passing that on the David channel. Is that right?
Yes.
So at David is a channel, and we've passed the quoted string, which is only a string. We've passed that on that channel. Then line 3, right, we go into a for, and we're saying that now pass a channel, which is Ned, and pass the channel Ned over to ball, which is what at this point? What is ball on line 3?
You're passing ball to Ned.
Oh, it's the other way. Okay.
On line 3. Yes, it's the other way. Ned is a channel still, and ball Now, ball is a process, but whenever you're receiving, remember, ball is a process from here. But whenever you're receiving, it is regarded as a name and not a process, or it is treated as a name and not a process. It's
So
pretty confusing at first.
Okay, but I think we could get it. So in line 1, when you did quote, ball, quote, you were defining a process. Is that what you're saying? Okay, so then on line 3, the process.
Yes, you were sending the process. Yeah.
Okay, so and it just gets created like a variable, right? So in line 1, we're just creating a process called ball.
Yes.
Okay, and we're sending that to the channel David. And then in line 3, with the for, we're saying for this process called ball, we're now sending it the Ned channel.
We're receiving it. We're receiving it on the Ned channel.
We're receiving
not
ball.
sending. Remember, this is receive.
Okay, so that's
This
kind of back. Okay, it's kind of backwards, right?
Yeah. Well.
Okay.
Yeah. So we need to send the same ball. Okay. Is someone talking?
Okay,
Yes,
so
David. I really got insights.
Sorry, I didn't get that.
Priska, you want to speak? David, what I want to say is that, like, this at David is a channel, and then the ball there, the quoted ball, is kind of defining a ball, a name. Then this line 3 is like sending the ball, receiving a way in which the ball is being received in the channel David, or like, I don't know, this next is like sub channel under David as a channel. I'm really trying to grasp what's there, but I think I understand a bit of what Ned was trying to put through. Am I clear? Is that the correct way to reason it?
Ned is a channel independent of David. There are 2 different channels. So let's actually execute this and see what we're gonna get. Let's evaluate this. So what exactly did we do at David?
Then we look at it. Before it's like when Ned receives the ball.
Sorry, I didn't get that.
Please, can I respond?
We're saying, okay, we're sending sending a ball to David, and at the same time we're receiving a ball from Ned.
Yes.
And
Ned is sending it back to Victor.
Right, and basically we're, the rholang statements, all these parallel programs are all the things we're going to send and all the things we're going to receive.
Okay, it's kind of like you're passing the ball, right?
Yes, you're passing the ball from between different persons. So that's what it is. Yes.
All right.
Yeah. So it's like you're passing the ball. That's exactly what it is.
But David is going to have the ball. Nobody's reading the channel David, so nobody's going to receive the ball. Ned doesn't receive the ball because we don't send it to him.
Yeah, we did send the ball to Ned.
Don't think so. We received a ball. Receive a ball from Ned. We never sent it.
I thought we read that for statement to mean.
Yeah, we did. Yeah.
Listen for ball on the Ned channel.
Right.
And when we get it, do the action, fire the ball on the Victor channel.
Right. And since we never sent the ball to Ned,
So are you saying this is supposed to be net?
That would work.
that would work, yeah. Okay, because then we send the ball to Ned, and then we listen for the ball on the Ned channel. And when we get the ball, we send it to Victor. There we go.
Okay, cool. So that makes a lot of
Wow.
sense. So, okay, so,
That makes a lot of
okay, cool.
Okay. 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 I think that makes a lot of sense. Yeah. Okay. Okay. So Ned has the ball, and we're listening for the ball in Ned, and then we send the ball to Victor.
Victor.
Okay. Okay, so let's actually try to print something on the screen. Let's get to print this on the screen. Yeah. Okay, so okay, I missed something. I think. So this here row IO standard out is used to print whatever is sent on the screen. Is that clear?
Yes, Dave, it's clear.
Yeah.
Yeah.
Okay, so if we go back here and we add that. And remember, if when using the new operator, there is no need to add and the quotes to the name again. So we simply remove the at and the quote since we've already, it's more or less like defining a variable in other programming languages. So it's more or less like we've defined the variables. Use this. Syntax error. Okay, we need something. Okay, so that's it. I think this should print on the screen now. This should print. Okay, so we can see that we've successfully passed the ball around. So it prints out ball on the screen. We send the ball on net channel. We listen for the ball on net channel, and then we send the ball to Victor. So it prints out ball on the screen. So we understand that, right?
David, I understand what you're trying to do, but I actually got lost where you mentioned that a standout was a kind of the code you are going to use to print the ball that is the I don't know how to put it, but kind of standard to use it to print out the movement of the ball, then it gets to Victor to print out at that stage. Can you please go back to that?
This row IO standard out is used to print on screen. Now, print on screen means show, or we could yeah, we could just call it show. So if you printing on screen and you check your and you're evaluating the code and you check your node, it's usually the one on the second line. Remember, if you watch the other ones that we've evaluated, we only get one line codes, and that's because we don't have a print on screen. So on adding the print on screen, it simply prints out the process that.
Okay.
Yeah, maybe we're taking it too much at a time. Let's just do something really basic. Let's start by printing your name to the screen. So we say new name. So who can help us with what we want to do if we want to print someone's name on the screen? So what do we need to add inside? What do we need to add here? So if you want your name to be printed on the screen, what would you need to write here? Okay, what we just simply do is, okay, Priska, you were saying?
The name you want to be printed.
You said?
I'm correct. I said the name you want to print on the screen.
Yeah, remember, you have to send that name. You have to send that name on a channel. So what you have to do is, we've already defined our channel here, name. So we say
Yes.
name, bang, then whatever name it is you want to print, let's say Priska.
Okay.
So Priska will get printed to screen. So
Yes.
let's actually check that out. So we say okay, I missed something here. Syntax error. Where is the syntax error coming from? Okay, well, in. Okay, so let's see what is our output there. So we can see it prints your name on the screen.
Yeah, that's too small for us to see. Oh, there we go.
Oh, do I need to increase the font size?
I see it now. It was just slow.
Oh, okay. Okay, so Victor, how do I print your name to screen?
Can you repeat the question again? How do you print my name? You mean how do
Yes, your
I
name
get
to
my
screen,
name
yes.
printed on the- I think first of all you have to run the
Yes.
first code, that's the name and the standout code. Then
Okay, so can you guide me?
Hello. Yes, you said name. Um,
Can you guide me to do?
hello, Dave. It's you're skipping, but I think what you do first is to get the name. You quote it to a channel, and then after that, the four. That is the four. You receive the name in a channel, and then you send it to another channel. I think there's new name. David, can you hear me?
Yeah, I can hear you. I can hear you.
Then you after that you write the name.
No, what you're saying is, what you're talking about is actually if you want to pass the name around. Now, we just want to simply print the name to screen. So there's no need to use
the standout.
a receive that is 4. Yes, you need this standard out.
Yes, standout. Row.
It's called standard out.
Standard out. Okay, thank you. Okay.
And those are single quotes, and you have to do the whole thing, RHO colon IO colon, stand it out.
Yeah, that's the command that is used to print to screen.
Okay.
I think it was changed in a recent version. Formerly, it wasn't. You didn't require that. So I think version. I don't know exactly the version. So it's more or less a recent stuff. So because formerly you didn't require that to print the screen.
Okay.
Yeah. So say name. Remember, we could call this channel anything. It doesn't have to be named. We could say ball. We could call it scene. We could call it just anything. It doesn't have to be a particular name. So team rchain. So this also should print rchain on the screen.
Okay.
So if we, yeah, so if we get to evaluate that new team standard out in scene rchain. Yeah, so
Okay.
this should print.
Okay.
It's supposed to print. What did we miss?
Maybe I missed something back there, but how are you doing your input on one screen and then getting your output on another screen?
Okay, this is, you mean on one terminal and getting the output on another terminal?
Yes. How did we start doing that?
Okay. What I actually did is this is a node running here, a standalone node, and then we fired up the REPL environment in another node. Where? In another node. Where is it? Here. So we have the REPL environment and we have our node running. So that's simply what we did.
Yeah, the output
So
goes.
this REPL is connected to this node. Whatever code you write in here is evaluated by the node.
Yeah, it's the
Yeah,
standard.
so a little debugging. Yeah, Jimmy, you're talking.
Yeah, the standard output goes to the log, Gary. So you just look at the log to see the output.
Okay, I think I understand that.
Okay, so let's move on. Okay, that's cool. I think the next thing we're supposed to look at is perform concurrent operation. So now if we observe, I think in one of our previous code where we're passing the ball around, we used this operator, a straight line, a vertical bar, and it's called the parallel operator. It's used to run concurrent operations. You know, normally a normal computer by line executing the instruction one after the other, but with this parallel operator, it enables code to be run at the same time. So the compiler and interpreter doesn't read the code one after the other. It takes them concurrently. So that's the function of the parallel operator. So if we say at then let's say for rchain see then let's say we send the process back to David. Rather we asterisk this and say rchain. Okay, so what is going to happen here is that these two instructions are going to be run simultaneously. So it won't be run one after the other, but they will be run at the same time because of the presence of this parallel operator. So does anyone have any comments or question on that?
I don't think I have.
Again, I didn't get the last thing you said.
I said the parallel operator, it allows two rholang instructions to be executed at the same time. Do you get that?
Yes, thank you.
Okay. So if we should execute this now, these two will be run at the same time. So let's try to deploy that. Say deploy.
So, you know, you're listing
Okay. If we
or you're going to send rchain to the standard output, okay, and at the same time you're waiting.
I didn't hear you.
Okay, so in this thing, you're writing output to the standard output, and at the same time, you're waiting to receive rchain on the team channel, in which case you send rchain to the David channel. Okay, but you're never going to execute the second part because you're never going to receive rchain on the team channel.
Yeah. Because it's already consumed by standard out. Now you know that this team is different from this team. These teams are not the same thing. This is a different channel from this.
David, why is it so?
Is anybody confused on that?
Yeah, I am.
I am too.
Same here, David.
Okay, now the reason it's different is that when we use the new operator is used to bind a name or a channel. And so we've bound this name team just to be used inside this curly braces, the let operator in JavaScript. So, you know, if you're using let operator, you're only using it within a function in JavaScript. So it's quite similar. The new works in that kind of fashion to let for JavaScript. So if you're using let in JavaScript, it only works in a function, unlike using var or const.
Right. You didn't. Yeah, I was thinking that we were still in the new there. Yeah, the end of the team.
So is it clear now?
The new team only applies from the between the curly braces that it's in. So outside the curly braces that the new team is in, that team is not defined. Is what. So I see that now. So you have a.
Yes, it stops here. Yeah.
Right. Okay, but since you never send rchain to team.
Okay, better.
Yeah, since you never send rchain to team outside of the new team, it never gets sent to David.
So is anyone else confused with that?
I'm not sure. Am I confused about it? I mean, you know, you're listening for rchain on the team channel, and as long as you never get that, you're never going to send the rchain to David, right? You know, what you're doing in rholang is you're saying,
yeah, you're saying, Jim, are you done talking?
Here's all the things I'm going to send, and here's all the things I'm going to receive. Okay, and okay. If you don't have...
Let's
I think we're losing you again, David.
Okay, let's get to evaluate that and see the results to get from that.
So you lost David again. Oh, he's back.
Yeah, sorry about that. Can you guys hear me now?
Yes.
Yes, I can hear you, David.
Yes. So I was saying, let's get to evaluate that and see the results we're gonna get. Okay, so then we get to check our. So, Jim, can you see that it prints our chain?
Okay, so let's see the log. Can you put the log up next to the ripple so we can see them both?
So is there any confusion on that?
So the only thing it did was the first part. It printed rchain to standard out. It never did the other. It never did it, the second part because
It actually did execute the second part.
If you were to do a 4, if you were to write on the channel, then it'll do the next part. If you write rchain on the channel team now.
On which channel? On which channel?
On the global team channel. Okay, then it'll write rchain to the David.
This?
Yeah, that's a different team. We already established that. Not the same team. It's a different team. Okay, so the first part wrote.
Yeah, you mean this one?
That one, right? So if we write rchain to that to the global team channel now, then rchain will get written to the David channel, and then
is this what you mean? Is this what you mean?
Right, and then in parallel with that, you do the 4. Right. So you want to do the 4 in parallel with that.
You know why I feel for this is because Now, printing a process to standard out doesn't get the process consumed. It only gets the process to print, but the process is not consumed.
But
did you hear me?
yeah, but that that team is not the same team. So right? That's what we said. That new team is only name only applies inside the braces there. So
yes.
Okay, so and that team is actually standard out, right? This team down here is a regular channel, okay, and we write rchain to that, and then with the for comprehension below, then we'll see the rchain on that channel and send rchain to David, okay, which still isn't printed, but we could do for David and we could print it.
Okay, let's try to evaluate this. So we're still getting the same. Okay. I think the difference between these two is just the extra new channel. It's the extra new. I don't think this is different from the previous code we wrote without this rchain team.
Well, I guess so. I don't see anybody who sent rchain to team, so I don't see how. I don't think there's anything on the David channel. The difference is that now something's on the David channel. Now rchain.
Yeah, but this team sent rchain. This first team sent rchain, and this rchain has not been consumed by any process before this.
We didn't write anything to the rchain. Wait. Okay. We just wrote the rchain to this standard out. I see. So so basically, there's nothing in team. I mean, team is gone anyway. I don't know. We can't read.
What team? You mean this one?
Yeah, that team is gone. Okay. We wrote rchain to it, and it's gone. Okay, now we have a new team. We have another team here, which is global because we didn't do a new. Okay, so now we write rchain to that channel, to the team channel, and now in the parallel process that we're listening for, rchain in the team channel, we get that. So therefore, we do the send to David rchain. Okay, we consume rchain from the team channel at this point. Okay, then we write rchain to the David channel, right?
Yes, right. But my point is,
if there's no
earlier when
if you take out that middle parallel process there of writing rchain to the team process, okay, when we come down to the for comprehension, nothing is ever written to the team channel, so it doesn't. We never receive rchain from the channel. And somebody has to write to a channel in order for us to read it.
and Sim here wrote to.
He didn't. No, he wrote the standard out. He didn't write to. He didn't write to team.
Yeah, but standard out doesn't consume processes, does it? Standard out only prints out processes. It doesn't get processes consumed.
Okay, you agree with me that the label team only applies there. We could call it team X or we could call it standard out. That doesn't change anything.
Yes, yes, I agree with that.
Okay. So how can we, okay, why don't you change the name team up top to standard out? So we don't get confused. Okay.
Okay.
Okay. Now, we have the, a for, we can put it first, the for comprehension of where we receive from the channel team rchain. And in order for us to receive something from that channel, some other process must have written something to that channel.
Okay.
Okay, so now we are writing rchain to the team channel. So the for comprehension will execute, and we're going to write rchain to the David channel. Okay, now if we
Okay, so let's try to make another process with this.
well, why don't we change the standard out. Why don't we write the standard out make that for comprehension. For David receives rchain. Where we receive rchain on David.
Yeah, I didn't get what you mean.
What I'm suggesting is that on line 2, okay, you say for rchain received from David. Wait, David.
On line 2?
Yeah. Now, it's not going to output rchain unconditionally if we put a for comprehension there. It'll only do that when Dave receives rchain.
Yeah, but Dave receives rchain here.
Right. Right. Dave receives rchain when team receives rchain. Or David is sent rchain when team receives it. Everything we send and receive is in here. What I'm suggesting is that we don't print rchain on standard out until we receive rchain from David. So we can say for rchain received from David, standard out, rchain received from David, or anything you want.
Okay, what if we make the standard out for all the processes by changing where this is? By changing where the curly braces end. So
Right.
it means that this standard out is for everything now, not just
Right.
this first.
So you're just writing rchain to standard out. That's unconditionally.
Yeah.
Now, what I was suggesting is that you only write to standard out when David receives rchain. Oh, never mind. Next time. In other words, it's like passing the ball, passing rchain from
So
from the team to David to standard out.
Sorry, guys, my computer keeps crashing today.
So why don't you oops, there goes David again. I'm not sure why we're not using rchain.cloud here.
We could try that. Anyway, I have a hard stop in a minute. When you guys are done, can you post the video? It might be helpful.
Sure.
Great. All right.
yeah, What are you working on now, Jim?
I'm sorry?
Yeah, what are you working on now? What are you trying to do?
Well, I was, yeah, I was just going to, add some logic to it. I'm wondering why we aren't using rchain.cloud for this. For learning rholang, it would be a lot easier, wouldn't it?
I tried using, I don't know if it's now working better, but I tried using it earlier. It got frozen. So that's why I left it.
Yeah, it's been frozen all day. I just checked it though. It is backing up now.
Okay.
So, yeah, the rchain.cloud, picks up stuff from the log nicely and shows you what happens. But can you copy and paste that example into the chat that we just did?
Okay.
And then I can show you what I was talking about.
Yeah. It's in the chat now.
Okay. Okay, well, I first partial error, what I do wrong.
Remove there's the par at line 9. Take out that par.
Just okay, so
Try again.
that runs now. Okay, it runs, but I don't know why. Okay, it output this. I guess and then it output rchain. So what I was going to do was put in a for comprehension here. What happened? It's not typing. And then I don't know if I need these. I'll put them in there. So now if it receives rchain on the tape, there it's going to put on the output from David. Here we run that. And we get rchain from David. Now, if I comment this out, okay, and I run it again, what? I still get rchain from David.
That's because that was what you said should be printed out to the screen. You didn't specify any other thing to be printed out to the screen.
I guess I have to figure this out. As far as I can see, we never sent anything to team. So David never got anything. And so therefore, this for comprehension should not have been executed. New action, doing 4x3 comes from David. X2 right. Rchain from David. Oh, obviously I don't understand.
Yeah, what I'm saying is, what you said should go to the screen is rchain from David. I don't know why are you expecting some other reply? So it's only print rchain from David because that's the only thing you said should be printed out to the screen. You didn't change that.
Right. What I changed was the for comprehension. I'm saying for rchain from David, do this. Is what I thought I was saying, but apparently not. Yeah. I take an example here. Oops. There's it. So I'll pass the screen back to you. I mean, I obviously have to study some more rholang. Understand what the for actually accomplishes. I mean, I'm listening on David. I look at this. Receive a message, do something here. Okay, in this example here, okay, contract is a for comprehension. where we give it an order we call coffee shop.
Contract
So this doesn't. Okay, let's just take this contract here and stick it here. And oh shoot, hit Control C instead of Control V. Okay, so we can say for
no, those are two different things.
order coffee shop. Okay, so that's equivalent to a contract.
No, it's not equivalent to a contract. What is equivalent to a contract is, instead of having dash, it's equal to. So for is not equivalent to contract. For is for persistence. If you want to do a persistent send. If you're looking, and contract is a syntactic sugar. If you look at it, the difference between receive and this is, instead of dash, you have equal to sign. So they're not exactly the same thing.
I see. So if I make this an equal sign here, that will be the same thing.
Yes, now you have a contract, yes. Something is missing. I think you need to remove the equal to sign by the right.
Mm-hmm. Coffee order received, coffee order received. Okay, so this is was my confusion there when here when somebody wrote this coffee shop, they received it. Let me just put the dash in here and see what we get.
What did you change?
I changed the equal sign back to a dash.
Okay, now it's a receive, not not a persistent send.
Right. And so we put this, you know, these are persistent anyway, in a sense. I mean, we put this in here, and whenever this gets executed whenever a coffee shop has a message in it, we'll get an order. But I don't know why we get the that other stuff. We put the equal sign back. Now we get evaluating here, and where we just get output here. Coffee order received. So what we would do here is we could do here is, I don't know how to do concatenation here. We can do at order. All right.
Now you know that the or the coffee shop is not a receive in this case. It's still a persistent for.
This is interesting. Why do we get coffee order received here and one hot chocolate? I think because we had it left over in the buffer. Or something. Let me run it again, see what we get. Now I get 2 large cappuccinos and one coffee order received. That was interesting. There was still, from the last time I ran it, there was something in the buffer. That we didn't read. Oops. See, now we got coffee order received here, 1 hot chocolate. Bizarre. Because standard out is not consuming it.
Standard out doesn't get consumed.
See how it's still getting coffee? Still getting coffee. Where is it getting coffee order received from? How come it keeps getting that?
That's because this is a persistent for, meaning that it is not supposed to change. It's supposed to remain constant, whether the input changes or not.
I mean, if I make this one very hot, chocolate. Very interesting. I keep getting coffee order received.
Yeah, you will keep getting coffee order received because you're having a persistent for, not a receive process. To make that a receive process, change that to a dash instead of equal to yes. Now it's a receive process. Yeah, so you see, you're no longer getting that.
And sometimes I get this extra output here. Not sure why that is. Sometimes it says this goes in evaluating. And then this is in the output. Then like every other time, I run it. Well,
Yeah, Jim, I've seen that happen on the rchain.cloud every time, nearly every time I try to run something. Sometimes that output is there, and then sometimes it just runs the output right up against the program. I don't know why it chooses to do that.
It must be a parsing issue. I mean, it's hard to parse. I mean, it's obviously parsing this stuff out of the log. Okay, because the output's all in the log.
Yeah, I thought it was a concurrency issue, but I'm in over my head. And not so much a concurrency with our program, but the way we've got rchain.cloud set up.
No.
But that doesn't seem to affect the program in any other way.
Does this scroll? No, not yet. All right. Look at that. So, you know, the main things about Ripple that's paid is that everything has to be on one line. And let me just try one more thing here. I'll share my screen again for a second. Actually, it'll be more than a second. Wow. So we go to test channel. I'm going to put this whole thing in here. Oops. I think I'll delete that. Oops. Not delete, not edit, delete. And start it with rholang colon so that it does something. And we've had some issues with that. We can look at the log, and let me go back. Looks like it added it. Proceed to deploy new fork choice. So let's see what it says. Where is it? Oh, it's right here. Yeah. Okay, it looks like they got success in deploying the block, but not implemented. And I don't see anything executed here. So basically, we wrote it on a channel in here, and then we read the result. And that probably isn't what we wanted to do. Okay, I'm done.
Okay, thank you, everybody. This was helpful. Thank you, David.
Thank you, Dave. It was very helpful and interactive.
Thanks, Dave.
Yeah, it's good to have all of you. It's good to have everyone of you around here.
Yeah, David, are you still around? Are you going? Are you sleeping? Thank you.
Yeah, I have to go now. Yeah, some things I would like to get fixed for tomorrow.
Okay. Thank you very much.
Yeah, we'll get to talk some other time.
Sure. Okay.
All right, bye, guys.
Bye-bye.
All right.